Hello, welcome to my Pre-Algebra review series. This video covers Chapter 5, Section 7, titled Solving Equations by Adding or Subtracting Fractions. By the end of this section, you'll have reviewed the procedures for using subtraction to solve equations, and you'll have reviewed the same process for solving equations using addition of fractions. Additionally, you'll be using mixed numbers to solve equations. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Objective 1. Using subtraction to solve equations. You solve equations with fractions the same way you solve equations using integers and decimals. This is done by using inverse operations and the properties of equality. Okay, example 1. It's a real-world problem we're going to solve here. So it says in 1999, the average household in the United States recycled about 1/4 of its solid waste. The Environmental Protection Agency, the EPA, has set a goal of recycling at 1/3 of the solid waste. So how much would the average U.S. household need to increase its recycling by to meet the EPA goal? So if we to write this down into words, we're going to come up with an equation here. So we're going to say, in words, we're going to say, what fraction of the U.S. households recycle plus the increase is the EPA goal. And we're going to let n be the increase. And the equation is going to be 1/4. So right now that's 1/4 of the solid waste is currently being recycled. That's the beginning part of the question. The question right here, this is the beginning. 1/4 of the solid waste plus the increase. The increase is whatever that number is. We're going to say the increase is n, and then is the goal, and the goal is 1/3, right? 1/3 is the EPA goal right here, 1/3. So the equation, 1/4 plus n, so n is the increase. We start with the fourth. We're going to add the increase. We don't know how much that is. It's some amount to get to 1/3. So writing the equation out here, it's 1/4 n plus n equals 1/3. And we're going to solve this like we do all the other equations we've solved. We're going to, we have a plus 1/4 on this side, we need to make just the n by itself. So we're going to have to subtract 1/4 from both sides. So when we do that, we're going to get plus 1/4 minus 1/4 plus n is equal to 1/3 minus 1/4. Right here, minus 1/3 minus 1/4. So what's going to happen is these are going to cancel, and we're going to be left with n on the left-hand side. And then we're going to have on the right-hand side, we're going to have 1/3 minus 1/4. Well, we're going to go ahead and do that subtraction. In order to do that, we're going to have to get a common denominator, and we're going to have to convert the numerators accordingly so that we can subtract them. So what we're going to do then is we're going to do a cross multiplication, as they call it. First of all, we're going to multiply the denominators together, which is 1/3 times 1/4, right here is 3 times 4. That's going to be 12. And then we're going to take the numerator over the third's numerator, and multiply it by the denominator of the other fraction, which is the fourth. So 4 times 1, here's the 1, here's the 4, here's the 1, here's the 4. 4 times 1 minus 3 times 1. And when we do that, we're going to get 4 minus 3, right here, 4 minus 3 over 12. And 4 minus 3 over 12 is 1/12. To meet the EPA's goal, the average household must increase its recycling by 1/12 or more solid waste. Okay, example 1a. Check your understanding. Since it says 1a, we're going to assume that there's another sheet, so there's probably another problem on another slide. but we'll go with these two for now. And we'll pause and let you look at them and do them and then come back. So go ahead and pause. Okay, now that you're back, it says solve and check. So let's start just by solving this. So when we look at this equation, y is equal to 8 ninths equals, excuse me, I had a bit of a cough there. Y plus 8 ninths equals 5 ninths. Let's write this. And I'm going to skip some steps. I usually always rewrite the problem, but right now, since I tend to run out of room here, let's just start off by getting the y by itself right from the very beginning. So we're going to have y plus 8 ninths minus 8 ninths. That's how we're going to move the 8 ninths away from the y. And that equals 5 ninths minus 8 ninths. Whatever we did to one side of the equation, we added this 8 ninths over here. We have to do the same thing. So when you add this 8 ninths, you must add that 8 ninths. So when we do that, these two disappear because 8 ninths minus 8 ninths is 0. And we end up with y equals 5 ninths minus 8 ninths. And we know now from earlier slides that when the denominator is the same, you can just treat the numerators as whether you're going to add or subtract. Not a problem. Just go ahead and do it. So in that case, we're going to get 5 minus 8 over 9. And what is 5 minus 8 over 9? Well, it's a negative 8. So what we're going to do is we're going to subtract the 5 from the 8 and get a 3. And then you use the sign of the larger number, which is negative. So it's negative 3 ninths. And negative 3 ninths gives us what? We can reduce this, right? So that equals negative 1/3. And I'm starting to creep into the other area over here. Negative 1/3. So that's our answer at this point. So now what we want to do is we want to check. It says, and check each, right? So we're going to go ahead and substitute in for y our result, minus 1/3. But we can make it easier on ourselves because we know the denominator is 9 in the problem, and this is a denominator of 9, so we can just substitute the minus 3 ninths instead of the minus 1/3. Just save ourselves a step. So because since the denominators are all 9, we can just use this one instead of the final answer here. So I'm going to say minus 3 ninths plus 8 ninths. That was the original equation, y plus 8 ninths, and that equals 5 ninths. 5 ninths. So now the question, is that true? So if I take 8 and I subtract 3, do I get a 9? I mean, a 5 rather? That equals 5, correct? So 8 over 9 is 5 over 9. The answer is match. 5 ninths, 5 ninths. Let's do B. So 2/3. I do have more room, so I guess I could have rewritten the problem. I think I still have room. So over here on B, we're going to say, I'm going to write out the whole problem. 2 divided by 3 is equal to u plus 3/5. And what do we want to do? We want to get rid of the 3/5 on this side, on the right-hand side, and move it to the left-hand side. That way the u will be by itself on the right-hand side. So in order to do that, we're going to take and move the 3/5 to the left-hand side by subtracting 3/5 from both sides. So I'm going to say minus 3/5 plus 2/3 is equal to u plus 3/5 minus 3/5. And these plus and minus 3/5 cancel each other out. And these, so we're left now with minus 3/5 plus 2/3 is equal to u. So now what we have to do is we're going to have to come up with a common denominator, right? In order to do that, the simplest thing we've learned to do is multiply them. Okay, so if we multiply them, there's going to be a 15 in the denominator, but in order to multiply these two together, whatever we multiply this denominator by, which is the 3, we got to multiply the numerator by that 3. So it's going to be minus 3 times 3 over 5 times 3, and then it's going to be plus 2 times 5. 5 times the 2, 2 times 5, 3 times the 3, negative, okay? And then that's in the 15 on the bottom, 5 times 3. So that's going to equal to 10. I'm going to switch these around because of the subtraction. I'm going to swap places on these two. So 5 times 2 is 10, minus 3 times 3 is 9, all over 15. And what does that result in? 10 minus 9 is equal to 1/15. There's our result. So now it said we want to check it. So how are we going to check it? We're going to take and find out if we put 1/15 in here in place of the u, 1/15 right here, and see what it comes out to. So I'm going to say is or does, let's say 2/3 equal to 1/15 plus 3/5. Okay, in order to do that, we're still going to do the cross multiplying and do the denominators as we've seen before. When we end up here, we're going to end up with 5 times 1 is 5, plus 3 times 15 is 45, over 5 times 15 is 75. And if we take when we complete this, we're 5 plus 45 is equal to 50 over 75. And can we reduce this? Well, we certainly can. We can subtract something from here, can't we? We can subtract or divide out, not subtract, divide out a 25. 25 goes into 52 times, and 25 goes into 75 3 times. And is that 2/3 the same as the 2/3 over on this side? It is. So these two are equal to each other. Okay, good job. Let's move to the next slide. Okay, for example 1b, which is our final question in this check your understanding, we're going to do the same as before. So now we have c right here. C plus 3/10 is equal to 11/15. They want us to find c. Okay, so we're going to get c by itself, leave it on the left-hand side. We're going to move the 3/10 to the other side. So we're going to have 3 plus 3/10, c plus 3/10 minus 3/10 is equal to 11/15 minus 3/10. It's the same negative 3/10 on this side that I have to take out on both sides, right? So in doing this, we did this so that we could get rid of the 3/5 on both together here with the c. So now these two numbers cancel each other out, and we end up with c equals 11/15 minus 3/10. Okay, let's see how this comes out. So what we're going to do, we're going to end up multiplying the denominators together. But before we do that, which will give us 150, we're going to multiply the 11 by 10. So we're going to end up with 110, okay, minus 3 times 15. 3 times 15 is 45. 15 times 3, here's your 3, and here's your 15. And that's going to be over, as we said before, 150. Okay, so now 110 minus 45 is 65 over 150. Okay, so what can we reduce this? Obviously, yes, we can. We can divide by 5, can we not? So if we divide by 5, we're going to get 13, because 65 has 13 5s in it. 13. 50 has 10 and 15. 50 and 15 is 65. 15 has 3, so there's 110 plus 3. All over, since we divided this by 5, we're going to divide the bottom by 5. And how many, what do we get? It's 30. 30 divided by 5, we get 30. 5 goes in here 30 times. And that is the answer I would contend. And now we're going to see if it's correct. We're going to replace the 13 30s and C, okay? So we're going to say now, we're going to say 13 over 30 plus 3/10 is equal to 11/15. And that's a question. It's, is it equal to, right? Is it equal to? So, in order to do this, we're going to do the same thing we did up here on the top. We're going to multiply the denominators, at which point we'll get 300. Okay? 10 times 30 is 300. And we're going to do 10 times 13. 10 times 13 is what? 130. And plus 3 times 30, which is 90. And what does that equal to? So it's all over 300. And 130 and 90 is going to be 200. It's 70 to 200, and we have 20 left over. So it's 220, okay, over 300. So now, what does 220 over 300 equal? What could we divide? We could divide a 10 into here, and we get 22 over 30. Well, 30, they're even, so we can divide them both by 2. So that'd be dividing the whole thing by 20. So I'm going to say 220 divided by 20 gives us 11. And 300 divided by 20, there's 5 20s in each 100. 5 times 3 is 15. Excuse me, I had a brain meltdown there for a second. So the answer here is 11/15, and that 11/15 does match the 11/15. So this answer is correct. So objective 2 says using subtraction to solve equations. The simple statement, you can use addition to solve an equation involving subtraction. It's a simple statement. Let's find out if it's what they say, if it's true. Okay, example 2, adding a fraction to solve an equation. So we're going to do as usual. We're going to try to get the n by itself on the left-hand side this time. And in order to do that, we have to move the negative 3/4 to the right-hand side. In order to do that, we're going to have to add a positive 3/4 to the side with the n. So n minus 3/4 plus 3/4 is equal to minus 5/8 plus 3/4. Okay? So now that we have that, as before, we know that these cancel because we intended them to. That's why we did this maneuver here. And now we have the n by itself. Oh, not an a. I guess I'm getting a little carried away here. N by itself equals, come on, ink, there you go, equals. So now we have to multiply our denominators to get them, because you need a common denominator. And we're going to cross multiply the numerators and the opposite denominator to compensate for the fact that we're adding in, multiplying by that many for the denominator. So it's going to be, and it ends up being equal to 5 times 4 plus 3 times 8. 5 comes up here in the numerator up here, the 4 over in the denominator over on the 3/4. The denominator for the 8th gets multiplied by the numerator to the 3 from the 3/4. And all of that is over 32. So once we do that, we can carry all the math here. We have negative 20 plus 24, which is 5 times 4 is 20. 3 times 8 is 24. It's a negative 20, and that's all over 32. And 24 minus 20 is equal to 4. Still over 32. And we can reduce this fraction, this 4/32, down to 1 over 32 divided by 4, 8. There's the solution. 1/8. Okay, example 2, under check your understanding. Solve and check each. So let's go ahead and do it. Why don't you take a break, not a break, but take a moment from the video and do these problems, and then when you return, we'll solve them together. Okay, now that you took the break and you're back, let's go ahead and work on problem A, which says A minus 3/5. So I'm going to write that down. A minus 3/5 is equal to 1/5. I think this one's going to come out pretty simple. So, and what do we have to do? Everybody knows we want to get the A by itself. That's the first thing you say. How do we solve this? Get the A by itself. Where is the A? A is on the left side. Well, let's leave it on the left side. It won't hurt anything to be on the left side. A, in order to do that, we're going to have to add 3/5 to get rid of the negative 3/5 on the left-hand side. So we're going to, in fact, we're going to add this positive 3/5 to both sides. Because you have to add something on one side, you have to do the exact same thing on the other side. So now we have A minus 3/5 plus 3/5 is equal to 1/5 plus 3/5. Okay, and we did this to get the A by itself, so that means now, if this is done right, minus 3/5 plus 3/5, this pair will go away, and we're left with the A on the left-hand side, and we have a 1/5 plus 3/5. Well, if the denominators are the same, we have nothing more to do other than to solve the problem by adding the numerators. I said it's plus in this case. Could be negative. We'd subtract the numerators. In this case, we're adding them. And what's the answer going to be? It's going to be 1 plus 3 over 5. And 1 plus 3 over 5, I'll do it right here. A is equal to 4 over 5. So the answer here is 4/5. And it says to check. So we're going to put 4/5 in place of A above. So A is equal to 4/5. And then it says minus 3/5 is equal to 1/5. And the question is it equal to 1/5? Is it equal to 1/5? Well, since the numerators are the same, we can just, it's a common numerator, we just have to take care of the mathematics of the numerators. The denominators are common. So 4 minus 3 is how much? 4 minus 3 is 1/5. And does that equal to 1/5? It sure does. That one's solved. Now let's do the other one. Pretty much the same as before. This time the x is where? On the right. So we're going to leave it on the right. In order to do that, we're going to move the negative 2/7 to the left-hand side. So I'm going to just start off by writing it. I'm going to say 6/7 plus 2/7. Why plus 2/7? Because we have a negative 2/7. We have to add 2/7 to each side to get rid of the negative. They have to cancel out and become 0 on the right-hand side. Equals x minus 2/7 plus 2/7. And this pair of numbers right here will disappear. Goodbye. And there's a common denominator, so all we have to do is do the mathematics relative to the numerator, and the mathematics here is 6 plus 2, 8 over 7 is equal to x. Well, 8 over 7, I'll bring it over here, is equal to 8 over 7 is 1 1/7 is the answer there. But now they want to know it does, according to check, it says to check our equation. If we put in, well, instead of the 1 and 1/7, we're going to put in 8/7. If we put 8/7 in here in place of the x, what will we get? Well, let's do it. 6/7 is equal to 8/7 minus 2/7. And all the denominators are the same, so all we have to worry about is the mathematics of the numerators. And that equals 8 minus 2, 8 minus 2/7 equals, 8 minus 2 is 6/7. Does 6/7 equal 6/7? Yes, it does. Okay, so here with example 3, it says using a mixed number to solve an equation. So we're dealing with mixed numbers now. And there's really no difference in mixed numbers and fractions or even improper fractions for that matter. What we will have to do, though, is convert the mixed number to an improper fraction in order to do the mathematics. So we want the common denominators. Okay, so we're going to start off. We're going to rewrite these and get rid of the mixed numbers and make improper fractions. So in order to do that, what do we get? We get p minus what? 1 3/5 is equal to 1. 1 times 5, 5 plus 3, 8 is equal to 8/5. And that equals to 2 times 4 times 2 is 8 plus 1 is 9. 9/4. Now this problem looks just like all the rest of them we've been doing does. We're going to get the p by itself, if you recall. We got to get the p by itself. And in order to do that, we have the 8/5 here. We have to, it's a negative 8/5, so we have to add a positive 8/5 because the positive 8/5 and negative 8/5 will cancel out. And then we're going to get 9/4, and we added a positive 8/5. Got to do it on this side too, 8/5. And when we do this and solve this, we're going to see that these are going to disappear. That was the intention. That's why we did this, to get the p by itself. And we're going to have p is now equal to 9/4 plus 8/5. And we can do what we've always done now. We're going to multiply the denominators, and we're going to cross multiply denominator to numerator to adjust the numerators for the fact that we're multiplying the denominators dependently on which denominator it is. So in order to do that, we're going to find out that we're going to have a denominator of 5 times 4 is 20. And we're going to take the 5 from the 8/5 and multiply it by the 9 from the 9/4. So we're going to get 9 times 5. And it's a positive, so a plus rather. So we're going to add a plus. And we're going to take the denominator from the 9/4, the 4, times the numerator of the 8/5, which is the 8. 8 times 4, 8 times 4. And we have the 20 in the denominator. So now I'll extend that a little bit there. So what does that equal to? 9 times 5 is 45. And plus 8 times 4 is 32. All over 20. Okay, so 45 plus 32 is how much? 45 plus 30 is 75, plus 2 is 77. So 77 over 20. Is there anything we can do with that? We can do a mixed number, right? We can convert this to a mixed number, and we're going to go ahead and do that. So we're going to end up with 20 goes into 77 how many times? 70 goes into 20 3 times, 60 3 times, and we're going to have 17 remainders. So and 17/20. That right there is our answer. Okay, example 3A. Check your understanding. It says 3A, and as before, you know that whenever this happens, we end up with more than one slide. So let's start off by looking at what they want us to do, is solve and check. So to solve and check, here's the equation. You have another one on another slide, but we'll do that. You can wait. We're going to do this slide first, and then we'll come back and do the next slide. So stop this video and go ahead and try the problem on your own. And when you come back, we'll try it together. Okay, now that you're back, let's see what we can accomplish here. So first, right off the bat, I'm going to convert the mixed numbers to improper fractions. So I'm going to get C minus 2 times 6 is 12 plus 1 is 13 over 6. And that equals 5 times 4 is 21 over 4. So now there's our new equation with the improper fractions. So, C minus 13. So now we want to get the C by itself. In order to do that, we're going to write the C. We have a negative 13 sixths. We have to add a positive 13 sixths. And then that equals 21 fourths plus 13 sixths. And as before, we can take these, and I'm circling them, but we don't have to do that. I'm just doing it to show you. Those are gone. So now our answer is going to be C is equal to 21 fourths plus 13 sixths. So at this point now, what do we have to do? We have to get common denominators so that we can add or subtract the numerators. In order to do that, so we can add and subtract the fraction itself. So to do that, I'm going to draw a line here. And on the bottom, I'm going to put 6 times 4 is 24. So that's our new denominator. And we're going to cross multiply the 21 with the 6. 21 times 6 plus 13, I'll extend the line, times 4. Do you see where we got those? The 21 comes from the left-hand fraction here, 21 fourths, and the 6 is the denominator from the 13 sixths. And then for the 13 times 4, it's just the opposite. The numerator from the 13 sixths times the denominator from the 21 fourths. Okay? And what does that equal to? So now C equals 21 times 6 is how much? 20 times 6 is 120. 1 times 6 is 6. So it's 126 plus 4 times 13. 4 times 10 is 40. 4 times 3 is 12. 40 and 12 is 52. And that's all over 24. And now we have to add these two together, the 126 and the 52. And the answer there is 126 plus 50 is 176. Plus 2 more is 178. And that's over 24. So now what we need to know is we have to turn this into an improper fraction. This is a harder number to work with, but let's see. I don't know, what do you want to do? You want to try and just divide it, long division? Let's see how that works out. So let's do some long division. 178 rather, divided by 24. Well, I'm going to say let's try the 20 into the 17. And how many times is that going? Of course, it's going to use the entire whole number here, the 24. But 2 into 17 is how much? 2 into 17 is 8, right? So if I do 8 times 4 is 32. Carry the 3. 8 times 2 is 16 plus 3 is 9. Oh, too big, right? So let me go ahead and erase that. Get rid of the 8. Let's try a smaller number. How about if we go 7? 7 times 4 is 28. And 7 times 2 is 14 plus 2 is 16. And that worked perfectly because now we have 178 minus 168 is 10. So our remainder is 10. So the answer here is going to, dividing this out, is going to be 7 and 10 24ths. 7 and 10 24ths. And you know that we can't leave it like that. So C is equal to what? C is equal to 7 and 10 divided by 2 is 5. And 24 divided by 2 is 12. And since there are no common factors here, that's the best reduction we can get. The simplest form we can put it in. 7 and 5/12 is the answer. So now we have to check it by checking back in. So let's go on this side, and let's replace the C, I'm going to rewrite it, with 7 and 5/12. 7 and 5/12 minus 2 and 1/6 is equal to 5 and 1/4. And we're going to get rid of these these mixed numbers and make them improper fractions. So 12 times 7 is 84. Plus 5 is 89, right? Over 12. Minus 2 times 6 is 12, plus 1 is 13. Sixths equals 5 times 4 is 20, plus 1 is 21 fourths. So now what we need to do is find out if the combination here, 89 twelfths minus 13 sixths, is that equal to 21 fourths? So in order to do that, we got a little bit of math to do here. We're going to take and I guess we're going to do 12 times 6. 12 times 6 is what, 72? Okay, let's see, I guess 72 and 72. And we're going to put that over 6 times 89. Oh, no, we have to do that. 12. No, we're not. I'm sorry. We're not going to do that. I'm going to do it a different way. I'm sorry. There's no reason to do it that way. Sorry for confusing you. I'm not going to get a common denominator. I'm going to make these two common in a way we haven't chosen before, but we've learned it before. So I'm going to say 89 twelfths. I need to make this a twelfths, the 6. And in order to do that, if I multiply the numerator and the denominator by 2 over 2, I can multiply any number here I want by 1. 2 over 2 is 1. I can multiply by 2 over 2. So I can say 13 sixths times 2 over 2. And that is equal to 21 fourths. And now that equals 89 twelfths. I'm going to draw a long line here because it's minus 2 times 6 is 12. 2 times 13 is 26. 26 over 12 is equal to 21 fourths. I hope everybody saw that. You're allowed to multiply any number you want by 1. It won't change the value of the equation. And we learned this before in an earlier lesson. So now we just have to subtract these two. And 89 minus 26 is 69. Minus 6 is a 3, so it's 63. So 63 twelfths. Is that equal to 21 fourths? Well, 12 goes into 63 how many times? 12 goes into 63 5 times. And 3 remainder. Right? Because 12 into 60 is 5. And then there's 3 left over. And over here is, does that equal to 4/21? What is 4/21? 4 goes into 21. How many? 5 and what? 1/4 remaining, right? So 4 goes into 21 5 times, and there's 1/4 remaining. Well, is 5 and 3/12 the same as 5 and 1/4? Well, if I can say that 3/12, I'll do it here. 3/12 is equal to 1/4 because I can multiply, or let's divide this. Divide the numerator by 3 and the denominator by 3, and I end up with 3 into 12 fourths. So these two are exactly identical. So now we're going to go to example 3b, checking your understanding. Here's the next problem. Solve and check. So we're going to start right off the bat. We're going to go ahead and let you take the time to solve it. And then when you come back, we'll finish them together. Okay? Now that you're back, let's start off by first, let's convert these mixed numbers to improper fractions, okay? So we're going to start off with 3 and 7/18 is 18 18 times 3 is how much? It's 8 times 30, and 8 times 3 is 24, so it's 54 plus 7, 61. 61 18ths equals Z plus 3 times 1 is 3 plus 1 is 4 thirds. Okay? So now the next step, get the Z by itself. And to get the Z by itself, we're going to leave the Z on the right-hand side. We're going to say, and now we're going to subtract 4 thirds from both sides. So I'm going to say 61 18ths minus 4 thirds is equal to Z plus 4 thirds minus 4 thirds. And now we've got this just the way we wanted it, because these two numbers are going to disappear. We have the Z left by itself. So now we have 61 over 18 minus 4 over 3 is equal to Z. So now we're going to add or subtract or whatever we're going to do on these two fractions. In this case, it's subtract. And we have 18. We could multiply 18 times 3 and do the cross multiplication with these large numbers. But the way I did it the last time seemed pretty nice. So I'm going to go ahead and say, let's do it again. In order to convert this fraction to 4 thirds into 18ths, we have to multiply this denominator by 6. Well, I can multiply the numerator and the denominator by 6 because it's 6 over 6 is 1. And I can multiply anything times 1. And we learned this in an earlier lecture. So, earlier review we were doing. So, I have 61 18ths minus 4 and over 3 times 6 over 6. And that equals Z. So now if I can take this 61 18ths minus 4 times 6 is 24 over 3 times 6 is 18 equals Z. So now I can subtract these. It's a common denominator and subtract these. 61 minus 24. 60 minus 20 is 40. 1 minus 4 is, I'm going to put us on the other side, it'd be 37. So we're going to end up with 37. I'm going to do it right here. 37 18ths. So let's convert this to a mixed number. 37 18ths converted to a mixed number is 18 goes into 37 2 times. 2 times 18 is 36. And there's one remainder, 1 18th. So the answer to this would be 2 and 1 18th. So now to check it, to see if it's correct, we're going to go back in and we're going to substitute 2 and 1 18th in for Z. Okay? And then find out if we end up with the same number. So we're going to go back over here and we're going to say 3 and 7 18ths is equal to Z, which is 2 and 1 18th, okay, plus 1 and 1/3. So we can do a couple things. We could, well, we'll just do what we want. So let's convert these mixed numbers to improper fractions. So 18 times, we'll go back to the same thing as before, which is 61 18ths. 61 18ths is equal to 18 times 2 is 36 plus 1 is 37. We know that. 37 18ths plus 4 thirds. 4 thirds. Okay, so again, we're going to add these two together. We're going to add these two numbers together, and if they come out right, so if we come out to 61 18ths, we win, right? So, and we can, in order to get this to be an 18, this one has to be an 18 to multiply. So we're going to multiply the top and the bottom by 3 times 6. So we're going to have 37 over 18 plus 4 thirds times 6 over 6 plus, oh, that's it, not plus nothing. Get rid of the plus, Bob. Get rid of the plus. Okay, sorry about that. So again, 37 18ths. Does that equal to 4 times 6 is 24? over 18 plus, what did I miss here? These two are all plus. And we got to get to this 81/18 over here, excuse me. So now, does 37/18 plus 24/18 equal 61/18? Here it is, equal 61/18. And let's find out. Here's the equal sign, 37 and 24. 20 and 37 is 57. Plus 4 is 61. 61/18. Does that equal to 61/18? I think it does. We win. Okay, good job, everyone.